Okay. Yes. So thank you for coming today and bring it on, Axel.
Yeah, thank you for the kind introduction. I'm pretty eager to present today, and I'm happy that you're here. So, yeah, let me briefly introduce myself. I'm Axel Langner. I'm a PhD student, and I studied biotechnology and biopharmaceutical technology, and then I switched to a high school teacher degree, and I was involved in different research. Um, on terms of biotechnology, but my main focus currently is educational sciences and eye tracking. And as Gitte said, I'm from Giessen. That's near Frankfurt, so somewhere in the middle of Germany. And there's also my awesome research group, the Graulich group, with my supervisor here on the left side. And yeah, without no further ado, let's start with eye tracking in science education. If you have any question, you can just type them in the chat. That's no problem. I try to answer them during the presentation or afterwards. And yeah, we have to move a little bit back in time when we start. Oh, let me first introduce the agenda. So I will introduce you to eye tracking, the method, how it functions. And afterwards, I will give you a broad overview about eye tracking in science education research. And then I will show you two of my projects, which I had led or I'm leading currently. And then we have time for the discussion in breakout rooms and the plenum discussion. Yeah, we have to go back in time, as I said. So around about 1970s, there was a researcher called Yarbus, and he showed people this picture and asked them different questions. For example, to just examine the picture. And then people showed an eye movement pattern like this. And then he asked them to remember the closest, and people showed an eye movement pattern like this. And then asked them to estimate the economic level, and people showed an eye movement pattern like this. And as Gitte said, Jarbus derived from this his study that the eye is interlinked with the brain or with the cognition of a person, which means when our brain directs our eyes, maybe we could measure the eye movements of people in order to infer conclusions about the cognition of a person. So, and this is more or less the basis of eye tracking. And there are some assumptions to do if you want to use eye tracking research. Here are some assumptions or the main assumptions which were used. First of all, the relevant information is in the center of the gaze. This is kind of a physiological thing because in order to see sharp, we need to redirect our eyes that the information is in the center of our gaze. And also there's the second assumption, which is called immediacy assumption, which says, okay, as long as somebody is looking at a specific element, a person is processing it. And then there's the eye-mind assumptions, which says, okay, when somebody is looking at the information, they are processing it. And when they change to look at the specific information, then they are not processing it anymore. So these are kind of pretty similar. So, and then you can tell me, okay, wait a second, Axel, I have experienced something different. I can look at a specific thing and think about something different. And you're absolutely right. Everybody's doing this. So, in order that these assumptions are valid, you need to direct the covert attention, which is the attention of the mind, and the overt attention, which is the attention of our eyes, is directed to the same stimulus. And this you can achieve by just giving people or a learner a purposeful task, for example. And then you could use an eye tracker. With these assumptions, you can use an eye tracker in order to measure the eye movements. So I will guide you through this picture. So here we have just a regular screen. The eye tracker is just this bar on the bottom of the screen, and it has infrared LED lights. these infrared LED lights sends infrared lights to the eye. It gets reflected, and then sensors in the eye tracker are recording the reflected light, and a pretty complex and also pretty expensive algorithm is calculating where a person is looking at. And this is how it looks like in the real world. So here I showed you on the schematic picture the screen-based eye tracker, and here you can see the screen on the bottom. Do you all can see my mouse? Okay, great. Okay, on the bottom you oh, sorry. Ah, no, I clicked. So on the bottom, you can see here the eye tracker, and just a person is sitting in front of the monitor. So it's a non-invasive method to record the eye movements. And here in my setting, this is a picture of my study setting. And here you can see I have a second monitor where I can look in real time, or I can observe in real time where a person is looking at. That's quite fancy. And another fancy tool is mobile eye tracking. Somebody is wearing glasses, and the eye tracker, this eye tracking bar here on the down on the bottom, this is just built into the frame. And here in the middle, there's a camera, and it records what the person is looking at. And then, for example, you can record something like drawing processes. And a newer application of this is kind of a merge between those two, screen-based and mobile eye tracking, which is just combining VR technology and eye tracking technology into one. So it's not like mobile eye tracking because it's not in the real world. It's more like screen-based because it's fixed and the participant is looking at the screen, but they can move in a simulation. So that's quite nice. That's some kind of which establishes currently. And what you get out of this after you've done the eye tracking measurement, you get a specific output. And one output is the fixations, which are mainly indicated in red dots, and they kind of getting bigger if somebody is looking at a specific element for a longer duration. And then we have saccades, which are the lines between those fixations, and they indicate in which direction a person is looking. And with this information, we can get what a person is looking at, how long they look at, and it gets bigger, the bubbles are getting bigger, and also in which order. This looks like this. Here I brought you something from my study. I'm a chemistry education researcher, so here my participants saw a big molecule, and they had the task to identify electrophilic centers, which is kind of reactive centers which chemists have to identify. And then we can get an IGS replay, which is kind of just in real time giving me the information where the participants were looking at. And also here in the middle, we have a static image of the eye gaze replay, which is called gaze plot. And you can also see small numbers in these bubbles indicating the order. And additionally, on the right side, you can see the heat map, which indicates where a person has looked longer at. So it's get more red if a person has looked longer at a specific element. And what you do when you do eye tracking analysis on the next step is that you set up areas of interest or define areas of interest. Imagine, for example, you have a stimulus, which is a picture and a text, and you want to know how often do your students use the picture or the text. So then you can define areas of interest in the software, which is just a rectangle, and then you can get out different metrics. It's a pretty extensive list. For example, the number of fixations, which is kind of how often did a person fixated on the picture, or the fixation duration, or the gaze proportion would be in which proportion is the gaze distributed between those areas of interest. Also, which is kind of interesting, maybe the transitions. So how often do students transition between text and pictures? And then the next step would be, you have all these data, you have now all the metrics and stuff like this. You're looking up and doing research, what does this mean? For example, what does a fixation duration mean? And then you're looking at the literature and you see, okay, somebody says fixation duration indicates the attention of a person. Somebody else says, no, it's information processing. Another one says, nah, it's an indicator for difficulty of the task or the element. Another one says, no, it's an indicator for the task complexity, distractors, task expertise level, and stuff like this. So it's kind of, the problem is that it really depends on the context. What metric what metric indicates what variable? Yeah, is it the attention? Is it information processing? Is it the expertise level or stuff like this? And this is also the case for all the other metrics, like the transitions you can see here on the right side. So if you want to do eye tracking data analysis, you need additional data. That's why you're using methodological triangulation in order to kind of back up your interpretation to make certain statements. And therefore, you can use, for example, questionnaires like performance tests, or you're using verbal reports, which are pretty straightforward, just asking the participant what they thought in a retrospective think aloud. So you just ask them what they did and what they thought, and they just describe it. And also biometrics could be used, for example, galvanic skin response sensors and stuff like this. Imagine this. You're just collecting the eye tracking data, and your participants are looking at a specific element for a longer duration. We don't know what this means. It could mean that they have specific problems with this element. It could mean that it's just interesting. Maybe they were looking at it, but thinking about something different. So we need additional data. And for example, if you give a questionnaire which measures the cognitive load, and a lot of participants just checking that they have a high cognitive load when they're looking at, and they have a long fixation duration on a specific element, you can derive, okay, they have a problem with this element. So that's why it's important to have additional data. And with this technique, a lot of eye tracking research happened in the last 10 years in science education research. So it kind of started on the last 20 years, but a lot happened in the last 10 years. And eye tracking, the methods of eye tracking technology is mainly used as a diagnosis and assessment tool. And I categorized the whole, the broad literature in different topics. You can categorize it in different themes as well, but I choose these ones. And maybe the list is not finalized. So for example, what happened a lot is problem-solving strategies, which you can see here on the left side. So for example, how do your participants or how do your learners solve specific problems? Also, what happened a lot is expertise comparison, comparing how an expert, for example, a professor or an advanced student is solving a task versus how a novice is solving a task. Then how learners use specific representations or different representations of the same phenomenon, and also evaluate learning materials. For example, simulations, videos, textbooks, stuff like this. And also, they try to measure the cognitive demand, like cognitive load or mental demand. This you could do with fixation duration, but also with the pupil dilation. Pupil dilation is the rate in which the pupil size changes. And another theme is the predictability of eye tracking data. Can we use eye tracking data to infer how good a student is, or also how well they will perform in a specific test, or will they be successful to solve the task or not? So a lot of things happened here, and I brought you some examples. Here we have an example about problem-solving strategy. The research group of Pascal Klein um, investigated how students look at vector field plots, and they analyzed the data. They did a lot of analysis in order to come to this conclusion. So I talked to him and he told me the story about this. So what they did here is they tried to get different metrics um, and compared them for correct students and incorrect students, and they saw no difference. And they were kind of okay, maybe there is no difference between those students in their gaze pattern. Um, but yeah, they did not know. And then they came up with the idea, hey, in order to solve the vector field plots, you need to look in a specific angles, vertically and horizontally. And then they looked at the angles of the saccades, these lines, and then they saw, okay, incorrect students mainly showed saccades in a horizontal direction. And then they saw, okay, that's the difference. That's what I meant when I told you before, it's highly context specific, which metric you use and what does it mean. Um, and also it's kind of an example, this one that it's challenging sometimes. And also it's kind of, I don't like it at some point because you're kind of searching in the data until you find something and then you report the difference. And I don't know if this is okay on an ethic perspective of research. It's just kind of like p hacking. I don't know. Okay, let's move on to the next example. Okay, here we have a usage of representation. Just how pupils are using the periodic table. And they were also looking at pupils who were correctly using the periodic table to solve a task, this task here, and pupils who were not doing it correctly. And they saw that all, or mainly, most of the students who solved the task correctly did not use the periodic table. They just memorized or guessed the answer. So as a teacher, we would say, okay, hey, they solved it. They know how to use the periodic table, but eye tracking data showed no, they did not. They were just guessing. So yeah, that's kind of funny and also some kind of result. And another one is from biology education, where they revised a book chapter, and used design principles. For example, here they integrated text into the picture, and then they eye tracked participants while they're learning with this, and it showed that the attentional focus was more on the relevant pictures in the revised version of the chapter, and this leads to the better students' performance. So we saw in the past that what often happens is that we have eye movements of learners, we have eye movement of experts, and they will show it to researchers, and researchers are analyzing this. But maybe there's more. Maybe we could also not just only use it for education research, but maybe we could also use eye tracking for education. And these are kind of the novel ways which kind of pops up in the last few years now. And for example, what if we show learners the eye movement of experts? And this is called eye movement modeling examples, which is used often in biology education and also medical education. For example, an expert is solving a problem on an X-ray picture of a chest, and this eye movement recording is shown to novices, and there is some kind of knowledge transfer happens. Then also we could use it maybe for teaching profession. Why not show teachers the eye movement of learners while, for example, they are learning with specific learning material, so that teachers get information how to design learning material, for example. And also, why not use eye tracking as a feedback tool, showing the learner their own eye movements in order to stimulate them, for example, to reflect about their own processing. And when we have a look at the literature, we can see, okay, a little bit happened in the past. especially for eye movement modeling examples in medical education and biology education. In physics education and also in chemistry education, nothing happened in eye movement modeling example. So for chemistry education, I can tell certainly. For physics education, I can say, okay, I did not had one publication in my hand about eye movement modeling examples. So this is where learners have seen the eye movements of experts. Then for teaching profession, really few studies. I just found two, and one of them is which I will show you later. This is one which I led. And the other one is using it. They were recording the eye movements of pupils while a teacher tried to direct their gaze in a physics experiment about light friction and stuff like this. So and then the teachers had the opportunity to revise their narration when they show the experiment in order to redirect the gaze of the pupils better to the relevant elements of the experiment. So, and then we have it as a feedback tool. There's also not nothing happened in order to kind of getting this reflection process. But I will also show you my PhD project with this. So, but first of all, let's start with the design of the multimedia learning materials and teachers revising it and reflecting about how learners learning with them. We designed in our for our student teacher courses a seminar where students were learning about multimedia design and multimedia learning, first of all, so the theoretical aspects of all the stuff. And then the students in our seminar designed learning material. It's the same content, but as a contrasting case. One time without the application of design principles for learning, and one time with the application of design principles for learning. And afterwards, our students were conducting a small eye tracking study with somebody else were using their learning material. And they had to solve tasks and stuff like this. And then the students were analyzing the data, and afterwards they were reflecting about their own learning material and also how meaningful it might be to use these multimedia design principles for learning. And it has shown that the course or the seminar supports the students, teachers in their creating, selecting, and designing their own learning material. If you need more information, feel free to send me an email and I will send you the publication, or you can just Google Langner and eye tracking, and I think you may find it. But if it's behind a paywall, just send me a mail. And another project which I want to show you, or another application which I want to show you, is using it as in an eye gaze augmented retrospective, the eye movements of their learners to stimulate them to reflect about their own problem-solving behavior. So, first of all, the participants had to solve a chemistry task. Like the one I showed you before, this is another task of my study to determine the configuration of asymmetric carbon atoms. So, and while they solved the task, they were recorded with an eye tracker. And afterwards, we showed them their own eye movements and asked them what they did and what I thought. So a regular retrospective think aloud. But additionally, in the second phase of this, we asked them reflection prompts like, were there something that surprised them? Did they notice specific areas where they're not well looking at or strongly looked at? And why is it like this? Would they change something for the future if they have, for example, a similar task, or would they even change the solution? And in a subsequent and in the final phase, we showed them the task solution and asked them, hey, what did you conclude? Why is it like this? Can they explain it? Why did they miss a spot, for example? And also, would they draw consequences? Would they change something for future problem-solving situations? And currently, or what I had done in the past few months, were I investigated the reflection, the structural complexity of this reflection process, which we stimulated with this retrospective, I guess, augmented retrospective, and we saw, okay, different patterns. And right now I'm preparing the manuscript for this. Hopefully you can read about this in the next month. Yeah, and there we'll discuss why we can see these patterns or why not. So when I want to focus more on the method, we can use eye tracking technology for learning. It seems like this. It's pretty promising. Maybe it's not efficient now, but yeah, it has the potential to do it. And in order to conclude all the things I said, so and come back also to the method of eye tracking, even you're using it as a diagnostic and assessment tool or for a learning tool, for example. So it's a pretty good sensor because it's objective and it's also non-invasive. It collects real-time data. The data is pretty rich and really detailed because also it collects not consciousness eye movement, it also collects unconsciousness eye movements. And with a pretty frequent measurement rate. And it's unique currently. So far as I know, it's the only method to measure visual attention. But it also comes with some cons. It's pretty expensive. So we are talking about thousands of euros for I think the cheapest one is round about the cheapest screen-based eye tracker. It's just a small bar which you pin down on the monitor, round about 2,000, 3,000 euros. And then you need to buy the software. And the software costs around about 10,000 euros for the first year. And then you can get a plan where you kind of pay like abonnement with 1,500 euros roundabout. I think we are paying currently. So yeah, it's expensive. It's also time consuming, planning a study, conducting the study, because these are just one-to-one sessions. And also, yeah, analyzing the data is time consuming and also challenging. So I have some thoughts about this. And these are just thoughts about, yeah, stimulating also you, and you can please add something if you have the additional thoughts. So eye tracking it's cool. It's a cool method. It's pretty fancy. That's why everybody is saying, oh, eye tracking, oh, that's so cool. And I try to use it as well in my future research. And I highly recommend it, but there's a big but. So it can be replaced by some methods. For example, if you're just using it to measure the cognitive load, you could use also a questionnaire, which is quite cheap. And also pupil dilation, for example, is the method. It's discussed if it's worth it or not. So some methods can be replaced, but not all of the method. It highly depends what you're looking for. And also the quality of research varies highly. So there are some papers which are pretty good and have a really good data analysis using really good metrics, combine them, and it's great. And also there are some publications out there which just look at the data qualitatively, which is fine to qualitatively interpret the data. That's not the case, but they don't back up their interpretation with additional information. So it's also, yeah, you don't know if it's like this or not. It's discutable. So, and currently there's a big potential in eye tracking. And in my opinion, every eye tracking research is also a methodology research, how to use eye tracking in science education research. We're not at the end now. So it's good to take this dive and just try it out at some point. Yeah, and now I have spoken a lot. Now it's your turn to do this. And I prepared two questions for you. First of all, what information does eye tracking reveal additionally about our learners? To answer this or to stimulate to think about this, I brought you two cases. One is Anna and Jessica. And then this happened in my study. They need to determine the configuration of aromatic carbon atoms. So they just have to look at two specific spots and then think about something. That's all information you need. And both of them, interestingly, gave here the same response, which is correct. and they gave no response here, but here's also asymmetric carbon. I prepared a document for you. I just have to copy the link in the chat. So here you can see a PDF file with some more data, eye tracking data about Anna and Jessica. Please compare them, and maybe it stimulates a little bit, yeah, what we can get out of eye tracking technology. And this should lead to the second question. And also, it is which question in the context of science education research would be meaningful to answer with eye tracking? You can analyze a lot with eye tracking, but the question is, should we do it? Is it worth or not? Which questions are worth it? And with this said, I am
Thank you
done,
very
and
much.
now it's your turn.
Wonderful, Axel. Thank you very much for this interesting talk. And maybe just before we go out into breakout rooms, we should remind ourselves that we know the technology behind the Tesla, and at a point the Tesla was very, very expensive. We don't know what is happening to eye tracking technology, but you never know. But let's go into the breakout rooms and let's definitely discuss when to use eye tracking technology in science education as well as in science education research. So have a good time out there and bring back some insights for a discussion in a plenary session, short plenary session after our